So I'm gonna spend the next 2 hours here doing this course on data visualization. I spent a bunch of time trying to install the binding library, but was a lot harder than I thought it would be. So since it's not something that is that much of a priority to me, I'm gonna focus on doing this instead and studying AI. And maybe I'll try again in the future. First introduction to coding for data visualization. In this hands-on course, you'll learn how to take on your data visualizations to the next level with Seaborn, a powerful but easy to use data visualization tool. To use Seaborn, you also learn a bit about how to write code in Python, other programming language. That said, the course is aimed at those with no prior programming experience. And each chart uses short and simple code, making Seaborn much faster and easier to use than many other data visualization tools. Coding environment. Take the time now to scroll quickly up and down this page. Notice there are a lot of different types of information, including text, code output. You refer to these pages as Jupyter notebooks. Set up the notebook. There are a few lines of code that you need to run at the top of every notebook to set up your coding environment. It's not important to understand these lines of code now. So this seems to be, of course, more for beginners than the previous two that I did. Load the data. In this notebook, we will work with a dataset of historical FIFA rankings for 6 countries. The dataset is stored as a CSV file. To load the data into the notebook, we will use two distinct steps. The method in the code cell below as follows. Begin by specifying the location or file path. So this is just teaching you how to do the first initial stuff. Examine the data. Now we take a quick look at the dataset in FIFA data to make sure that it loaded properly. We print the first 5 rows, plot the data. It's course to learn about many different plot types. In many cases, you only need one line of code to make a chart. For a sneak peek at what you learn, check out the code below that generates a line chart. So line plot, line. So I think if I had to do the courses again, this is probably the first one to start with. Seems to be more for beginners than the other ones. First, you learn how to run code and we start code source. So supporting pandas, matplotlib, Seaborn. As far as I understand, Seaborn is a subsection of matplotlib. It's a library that was built on top of matplotlib and has additional visualization features. Step 1. Explore the feedback system. Each exercise lets you test your new skills with a real-world dataset. On the way, you receive feedback on your work. I think, it's just telling you how to do Jupyter Notebook. Change the 2 to 1 so that the line of code appears as 1 plus 1. Load the data. This is just loading the file path and reading with pandas. Plot the data. Now that the data is loaded into the notebook, you're ready to visualize it. Run the next code cell without changes to make a line chart. So this is the same that they did on the tutorial. SNS seems to be to call the Seaborn and PLT to create the plot from matplotlib. Some questions won't require you to write any code. Instead, you interpret visualizations. As an example, consider the question. Considering only the years represented in the dataset, which countries spent these 5 consecutive years in the first rank spot? To receive a hint, uncomment the code below. So, which countries spent at least 5 consecutive years in number one spot? I don't know what the y-axis is. I don't know, don't feel like reading. It's not that important, to be honest. Just want to learn how to make animations in 3D graphs. The only country that meets the equatorial is Brazil. Yeah, I should have known because it's my country, but I'm trying to learn how to use the Twitter API as well. So I might add that on stream also. I'm not sure about it yet. Now that you are familiar with the coding environment, it's time to learn how to make your own charts. In this tutorial, you'll learn just enough Python to create professional looking line charts, set up the notebook, so import pandas, all this stuff, select the data set, load the data, examine the data, complete the first 5 rows of the data set using that. Check now the first 5 rows. Tail, I think, is the last 5 ones. Yeah. Empty entries will be appear as none. Plot the data. So data equals the data frame. Yeah. If you want to print the whole data frame. Really easy. I don't understand how this makes the y and x axis though. I don't think it's saying here. Maybe it's just, yeah, column. The x is the columns and the y is the, no, the x is the rows here. And the y, I think, are the values for each one. And each column is color here. Don't know if that's the standard way that the library works when you call this method. As you can see above, the line of code is relatively short and has two main components. SNS line plot, that was the notebook that we want to create a line chart. Every command that you learn about in this course will start with SNS. which indicates that the command comes from CBarn package. For instance, yeah, CNS heatmap to make bar charts heatmap to the effect. Selects the data, data equals, selects the data. Note that you always use the same format when you create a line chart. And the only thing that changes with a new dataset is the name of the dataset. Sometimes there are additional details we like to modify, like the size of the figure and the title of the chart. Each of these options can easily be set a single line of code. So plt.title makes the title. I guess figure is fixed size is the size of the graph. So x label equals date, center. The first line of code sets the size of the figure to 14 inches by 6. To set the size of any figure, you need only copy the same line of code as it appears. Then, if you'd like to use a custom size, change the provided values of 14 and 16 to the desired width and height. Second lines of code sets the title of the figure. Note that the title must always be enclosed in quotation marks. Plot a subset of the data. So far, we've learned how to plot a line for every column in the dataset. In this section, you'll learn how to plot a subset of the columns. We begin by printing the names of all columns. This is done. Okay. The next code cell will plot the lines corresponding to the first two columns in the dataset. Line chart showing daily global streams of shape. Okay. So instead of specifying the whole frame, it just specifies a single color. Add label for horizontal axis. T.x label date. So if you do this and you don't call, it's gonna store, I guess. Which one is gonna show? No, but here's shape of view only. The first two lines of code set the title and size. The next two lines add a line to the line chart. For instance, consider the first one, which adds the line of shape of view. These lines look really similar to the code we used when we plotted every line in the dataset, but it has a few key differences. So instead of setting data Spotify, you set data, yeah. So it's basically selecting the column. I don't understand why the y-axis is. Maybe it's just the value of the cells in each column, and that's probably what it is. And here it specifies the label of the x. This exercise, you use your new knowledge to propose a solution to a real-world scenario. Have recently been hired to manage museums in the city of Los Angeles. Your first project focuses on the first four museums featured in the image below. You leverage the data from the Los Angeles data portal that tracks monthly visitors to each museum. Setup. If not, os.path exists. Link. So I guess this is checking if the path exists, and if it doesn't, then it goes to other path. Your first assignment is to read the LA Museum visitors data. Please do not change the provided value of the file path. The name of the column chooses row labels as a date. It can be seen in cell A1. So I guess they just want me to do. In the line below to read the file into variable museum data. So let me read this. The file path to the dataset stars museum file path. Please do not change the provided value of the file path. The name of the column choose as rows labels is date. This can be seen in cell A1 when the file is open in Excel. To help with this, you may find it useful to revisit some relevant code from the tutorials. Oh, so I have to specify index oh, state. So this shouldn't matter as a index column I knew, but parse dates. I guess I knew from the other tutorials, but I forgot. Where they talk about the changing the encoding. Review the data. Use a Python command to print the last 5 rows of the data. So it's just the head now. Use the last 5 rows. Oh, it's the last. Also, it's tail. Thus, the last row tracks the number of visitors to each museum in November 2018. The next to last, the next to last row for tracks the number of visitors to each museum in October 2018. So use the last 5 rows of the data to answer the questions below. How many visitors did the Chinese American Museum receive in July 2018? So it's gonna be Chinese American Museum 1620. Just finding the values here. I don't think they want me to do lock and iLock because it seems like a easier tutorial. In the line below, October 2018, how many more visitors did Avila Adobe received in the Firehouse Museum? So October, let's use the calculator for this one. It's one minus the other. 14,658. Convince the museum board. The Firehouse Museum claims they ran an event in 2014 that brought an incredible number of visitors, that they should get extra budget to run a similar event again. The other museums think these types of events aren't that important, and budgets should be split poorly based on recent visitors on an average day. Show the museum board how the event compared to regular traffic at each museum. Create a line chart that shows how the number of visitors to each museum evolved over time. We should have 4 lines, one for each museum. Optional note, if you have some prior experience with plotting figures in Python, you might be familiar with the plot.show command. If you decide to use this command, please place it after the line of code to check that checks your answers. So CNS, I think it's uh, plot. Don't remember really well. Using data is the name of the thing. I know there's gonna be data equals using. And then I forgot. I have to look at it. A line plot. And then there's another argument there that I also forgot. Label. But I don't think this one needs because it's the whole data frame. It's probably just this. Assess seasonality. When meeting with the employees at a Villa Adobe, you hear the one major pain point is that the number of museum visitors varies greatly with the seasons. Low seasons when the employees are perfectly staffed and happy, and also high seasons when the employees are understaffed and stressed. You realize that if you can predict these highs and low seasons, you can plan ahead to hire some additional seasonal employees to help out with the extra work. Create a line chart that shows how the number of visitors to a Villa Adobe has evolved over time. What returns there? The first thing that you should check is that you've spelled correctly. So it's pretty much the same thing, but for the column now instead, I think. A Villa Adobe. Let me remember how the label is written. Yeah, I think that's what I'm supposed to do. Yeah. Part B, does a Villa Adobe get more visitors in September, February, LA, and the fall and winter months, or in the March, August, spring and summer? This information when should the museum staff additional seasonal employees? So I can't really see here. I guess gets more visitors in September, no, in March through August than in September to February. No, but I think that's it. Yeah, I think that's it. I'm not there. I don't see any place to put any more code. I think that's just the part B. Bar charts and heat maps. I'm gonna skip this parts. Since the dataset is small, we can easily print all of its contents. This is done by writing a single line of code. Bar charts. They'd like to create a bar chart showing the average arrival delay for Spirit Airlines. So it creates the figure size, then the title, CNS bar plot, bar chart showing average arriving delay for Spirit Airlines flights by month. So here's specifying the X and Y axis, add label for vertical axis. I don't see, I don't understand what's automatic default for the X label. It says month here. The commands for customizing the text, title, and vertical axis and size of the figure are familiar from the previous tutorial. The code that creates the bar chart is new. It has three main components. Bar plot, this tells notebook we want to create a bar chart. Uh, Flight data index, this determines what to use on horizontal axis. In this case, we have selected the column that indexes the rows. In this case, the column containing the months. Oh, that's why. It shows month here. Because it's taking the column of month. And I guess that's the default. When you have only one column. This sets the column in the data that will be used to determine the height of each bar. You must select the indexing column with flight data index, and it is not possible to use flight data mode, which will return an error. This is because when we loaded the data set, the month column was used to index the rows. You always have to use this special notation to select the indexing column. Uh, Heat map. I have one more plot type to learn about heat maps. In the code cell below, we'll create a heat map to quickly visualize partners in flight data. Each cell is color coded according to its corresponding value. So this one is the one that's used the most, I think, for machine learning and to find the correlations. The relevant code to create the heat map is as follows. SNS.heatmap data annotation. This annotation true equals true. This ensures that the values for each cell appear on the chart. Leaving these out removes the numbers from each of the cells. What patterns can you detect in the table? You've recently decided to create your very own video game. As an avid reader of IGN game reviews, you hear about all of the most recent game releases along with the ranking they've received from experts, range from 0 to 10. Setup, code checking. I need to study this OS module. I see that it is used a lot to specify file paths. I think it's because when you want to specify file paths and want them to keep working regardless if you change the files or not. That's why people use this. But don't understand exactly how it works and what are the most common ways to use. Read the IGN data file into IGN data. Use the platform column to label the roles. Platform. Use the Python command to print the entire data set. NS bar plots data IGN data. The data set that you just printed showed the averages score. Maybe I should do the fig thing. I think it's, I don't remember what you look at it. I think that figure. So I need to specify X. No, saying to print the entire data set. Yeah. So, but this doesn't look right. So I must be doing something wrong here. So maybe it's X equals the index and the whole thing is platform. No, the index is platform. So maybe Y is the whole data. I'll try the other way around. No, but that. Oh, so maybe if I do this stuff before. Yeah, Y X is the index, and Y seems to be the. This doesn't work, I think. So this seems to be correct. Bar chart showing average arrival. Flight data is the data set. Let's go move. I have to put a column there, but on the y axis. But they didn't tell me to create the head. And let's see if I did this correctly. Yeah. So I'm assuming it's supposed to only have one column. About the data. This is strange. I think I'm gonna have to check here. Each row corresponds to a different platform, and each genre has its own column. And entries contain the average score for each combination of genre and platform. Yeah, I have no idea if I'm doing wrong here. I mean, I don't think it makes sense that this is the way it's supposed to look like because they are overlapping. Well, maybe if I create a PLT figure first in size, and then I make the X equals index and Y equals. Maybe this works. It doesn't. I don't know. I'm gonna look at the solution. I don't know what to do. Print the data. Oh, so I'm not supposed to make a graph. It's just asking me to get the values. Yes, I'm just gonna copy this. I don't feel like looking at the data. It's just a waste of time. Each platform is best. Create a bar chart that shows the average score for racing games. Now I think I'm supposed to do the figure thing. Now let's see if it works. CNS, bar plots, x equals. Let me check the rows. Racing is with caps lock. Yeah, there we go. But it's still overlapping here, which is weird. There's something wrong with this. Oh, I forgot to put the label. Maybe that's no, but because here they didn't specify the X label as well. Let me see the solution. So it's the other way around that I'm supposed to do. But it's weird that it still gave me the correct answer. I guess they're not gonna talk about what you do when the values overlap. POT, X label. So it just by default it gets the name of the column, platform and racing. Based on the bar chart, do you expect a racing game for the Wii platform to receive a high rating? No. Not what gaming platform needs to be the best alternative. Xbox One. I don't think I need to type anything here. Use the data to create a heat map of average score and I think it's gonna be is the same way that the previous one works. So it works with the whole data frame. Yeah. Each combination of genre and platform receives the highest average rating. Each combination receives the lowest average. So far, this has been the easiest course so far. But I still have a lot of questions though. But guess I'll have to study separately later. Just waiting to finish this download stuff. The saving. Yeah, but I'm still halfway through, so don't know. Maybe it gets more difficult. No. To create a simple scatter plot, we use SNS scatter plot. So scatter plot above stress the body mass and the insurance charges are positively correlated. Our consumers with higher BMI typically also tend to pay more in insurance costs. To double check the strength of this relationship, you might like to add a regression line, or the line that best fits the data. We do this by changing the command to sns.regplot. Color coded scatter plots. You can use scatter plots to display the relationships between not two but three variables. One way of doing this is by color coding the points. For instance, to understand how smoking affects the relationship between BMI and insurance costs, and color code points by smoker and plot the other two. So hue makes it colorful. So it's the same data as before, but with the color for smoking. This scatter plot th- shows that while non-smokers should tend to pay slightly more with increasing BMI, smokers pay much more. To further emphasize this fact, we can use this SNS LM plot command to add the two regression lines corresponding to smokers and non-smokers. So X, Y. So two regression lines. So this adds regression lines, I guess. The SNS LM plot command above works slightly different than the commands you have learned about so far. Instead of setting X equals insurance data BMI, just select BMI column. In insurance data, we set X equals BMI to specify the name of the column only. Similarly, Y charges and Hue Smoker also contains the names of columns. Specify the data set with data, insurance data. Uh, Here. Finally, there's one more plotted to learn about. That might look slightly different from how you're used to seeing scatter plots. Usually, use scatter plots to highlight the relationship between two continuous variables, like BMI and charges. However, we can adapt the design of the scatter plot to future categorical variable like smoker. One of the main axes, one of the main axes. We will refer to this plot type as a categorical scatter plot, and we build it with the SNS swarm plot command. Yeah, I'm not sure if I understand this. It's building a graph of a categorical value somehow. Among other things, this plot shows that on average, non-smokers are charged less than smokers. The customers who pay the most are smokers. Where's the customers? Yeah. What did I do? Oops. So I'm not sure how this turns a categorical value into a map. I guess it's just taking the columns, the value of the columns for charges and plotting whether it smokes or not. But I don't understand this. How can I make this distribution here? So I'm not gonna read the production stuff. Read the candy data file into data candy. Use the ID column to label the rows. So it's same stuff we did so far. Review the data. Use the Python command to print the first 5 rows. Which candy was more popular? Survey response. Honestly, I'm just gonna look at the solution to this. Don't wanna just waste time. Because it doesn't have anything to do with coding, just looking at the data set. The role of sugar. Do people tend to prefer candies with higher sugar content? Create a scatter plot that shows the relationship between sugar percent on the horizontal axis and win percent on the vertical y-axis. Don't add a regression line just yet. We'll do this on the next one. So what's the name of the file? Candy data. If I remember correctly, that's how you do it. Maybe I'm missing something. You probably will forget this stuff as well, but it's good to just get practice, increases the chances of remembering stuff. Does the scatter plot show a strong correlation between the two variables? If so, are candies with more sugar relatively more or less popular with the survey respondents? Yeah, I can't see much of a correlation. Take a closer look. Part A, create the same scatter plot you created in step 3, but now with a regression line. I'm not sure. uh, The next one is the one that uses just the name of the column. Scholar, yeah. According to the plot above, is there a slight correlation between green percent and sugar percent? What does this tell you about the candy that people tend to prefer? So obviously, with more sugar. but I don't think you can trust this that much because you're looking at well, it's a problem of data. And step 5 chocolate. In this the code cell below, create a scatter plot to show the relationship between price percent on the x and percent on the y. Use the chocolate column to color code the points. Don't add it in your kind of don't add the regressions line just yet. Price percent. I think here's you. Let's see if that's yeah. Basically, create the same scatter plot you created in step 5, but now with two regression lines. Corresponding to one chocolate candies and two candles candies without chocolate. So I think that's the one that I'm just gonna put the name of the color. I have to look at. As this one. What? It's an L here. Plot. Oh, two regression lines corresponding to one chocolate candies and two candies without chocolate. Maybe I'm not supposed to do this. Yeah. Scatter plot shows that to further emphasize this fact, we can use as LM plot command to add two regression lines corresponding to smoker and no smokers. So yeah, that's what I'm supposed to do. But you'll notice that the regression line for smokers has much steeper slope. Works slightly different. Instead of setting select BMI. Finally, there's one more plot to learn. So that's the next one. No, so it is correct. In the regression lines, what conclusions can you draw about the effect of chocolate and price on candy popularity? So chocolate increases the price. Everybody loves chocolate. Create a categorical scatter plot to highlight the relationship between chocolate on the win percent. Put chocolate on the horizontal axis and win percent on the vertical y. Now is the swarm thing. Think it's swarm plots? Yeah, swarm plots. Just gonna copy this. It's better to copy this one. chocolate and win percent. Put chocolate on the horizontal axis. Cool. Which plots more profit to the store. I think the second one, step 7. And they're both kind of make the point. Okay, so 5, 6. Select dataset, load histograms. Say we would like to create a histogram to see how petal length varies in iris flowers. You can do this with SNS displot command. Customize the behavior of the command with 2 additional pieces of information. A equals chooses the column we'd like to plot. KD false is something we will always provide when creating a histogram, as leaving it out will create a slightly different plot. Density plots. The next type of plot is a kernel density estimate plot. In case you're not familiar with KDA plots, you can think of it as a smoothed histogram. To make a KDA plot, use the SNS KDA plot command, setting shade equals true. Colors the area below the curve, and data has identical functionality as when we made the histogram above. KDA plot. So shade equals true, colors the area below the curve. Colors the area. Okay. We're not restricted to a single column when creating a KDA plot. We can create a two-dimensional KDA plot with this SNS trend plot command. Plot below, the color coding shows us how likely we are to see different combinations of sepal width and petal length, where darker parts of the figure are more likely. So let's join each plots, each one. Note that the addition of to the KDA plot in the center. The curve at the top of the figure is a KDE plot for the data on the x-axis. In this case, iris data petal length. And the curve on the right of the figure is a KDE plot for data on the y-axis. Color-coded plots. For the next part of the tutorial, we'll create plots to understand differences between the species. To accomplish this, we'll begin by breaking the dataset into 3 separate files, with one for each species. In the code cell below, we create a different histogram for each species by using SNS displot command. Then it's gonna join us. In this case, the legend does not automatically appear on the plot. To force it to show for any plot type, you can always use plt.legend. You can also create a KDA plot For each species by using SNS KD plot. As above, again label equals is used to set the values in the legend. I'm probably gonna forget all of this very fast. One interesting pattern that can be seen in plots is that the plants seem to belong to one of two groups. Even though it's easy, it's hard to remember what each command does. I wish there was a course that explained the the library behind the each thing so you can understand better. I think that way it sticks more the information instead of just showing the commands, which is good as well, but would it be even better if there was a course showing how the libraries work behind the curtains? So I think here is just loading the stuff. I'm gonna have to reload the page. Get bugged. It's not letting me play this. What the index column here? I should just create a new cell. Copy this stuff. Yeah, there we go. Use a Python command to print the first 5 rows for the first data. B. Use first 5 rows of the data for benign myline thermus. Not sure how that's how it says. To answer the questions below. Uh, just gonna look at the solution. Investigating differences. Part A. Use the code below to create two histograms that show the distribution in values for area mean for both benign and malign tumors. To permit easy comparison, create a single figure containing both histograms in the code saw below. So I already forgot the commands. There's KDE equals false. I think I'm just gonna look the tutorial there. SNS this block. Maybe it has to be a column. Area mean for both of them. I'm not sure. Yeah, there's the column here. What? This plot's not defined. Oh, I have to put A equals. That's the problem, I think. This plot's not defined. What? Oh, maybe there was a typo there. So I should use label as well. Whatever. A researcher approaches you for help with identifying how the error column can be used to understand the difference between benign and malign tumors. based on the histograms above. The one-line terms have higher. I think this is just it there. A very useful column. Use the code style below to create two KDE plots that show the distribution in values for radius bursts. So it's the same thing, but for KDE. And then it was another argument here. KDE plot. Shade equals true. So here is radius first. Why it's not showing anything? Maybe I need to take the shade off. Yeah, not sure. Data. That's the issue here. I don't think it's gonna let me run now. But yeah, there we go. Nice. Hospital has recently started using an algorithm. I think that yeah, that's just questions about looking at the data. Since it's not always easy to decide how best to store behind the data, we've broken the charts types into three broad categories to help with this. Trends. A trend is defined as a pattern of change. Line charts best to show trends over a period of time. Multiple lines can be used to show trends in more than one group relationship. There are many different chart types they can use to understand the relationship between variables in your data. Bar plot, heat map, scatter plot, rag plot, swarm plot, distribution. We visualize distributions to show the possible values that we can expect to see in the variable, along with how likely they are. Visualize distribution. I haven't used joint plot in the last one. Maybe I should have done that. This command is useful for simultaneously displaying KDE plot with the corresponding KDE plots for each individual variable. Changing styles with CA-barn. All of the commands have provided a nice default style to each of the plots. However, you may find it useful to customize how your plots look, and thankfully this can be accomplished by just adding one more line of code. As always, we need to begin by setting up the code environment. Usually change so SNS.setStyle changes the background. Seaborn has 5 different themes: dark grid, white grid, dark, white, and ticks. And you need only use a command similar to the one in the code cell above. In the upcoming exercise, you experiment with these themes. So it's just SNS.setStyle, as far as I understand. Run the command below to try out the dark theme. I might skip this lesson. I don't see the point. I think this course was just a bit too easy so far. Like, they're not, but maybe there isn't much you can do with visualization libraries in Python. Is usually the problem is not the visualizations also as well, is the data and how to find the best way to represent it instead of drawing the charts. And that really depends on case by case basis. So there's 2 more sections. Hmm. So I think that's it pretty much on the data visualization stuff. Attach the dataset to the notebook. Begin by selecting a CSV dataset from Kaggle's dataset. For unsure how to do this, please revisit the instructions in the previous tutorial. Once you have selected a dataset, click on the Add Data option in the top right corner. This will generate a pop-up window you can use to search for your chosen dataset. Once you found the dataset, click on the Add button. Look for the input folder. So I'm not sure where I'm supposed to do this. Maybe the link will bring you a web page for collections. Note that the datasets you see on the page will likely look different from what's shown in the screenshot above. The following exercise will work with any CSV dataset of your choosing. As you learned above, Kaggle datasets contains a large collection of datasets that you can use. If you prefer to work with your own dataset, you need to first upload it to your Kaggle dataset. Attach the dataset to the notebook. So begin by selecting one. Customer personality analysis. Okay. I think at a first glance, this one gets more attention the most. Once you have selected the dataset, click on the Add Data option on the top right corner. Oh, here. So add data. This is generated pop-up is just search. Once you have found the dataset, click on Add Customer Personality Analysis. Yeah, it's this one. You can check that it was successful by looking at the data drop-down menu to the right of the notebook. Look for an input folder containing a subfolder that matches the name of the dataset. So here. You can click in the character in the caret to the left of the name of the dataset. To double click. Double check that it contains CSV file. For instance, check if uploaded a dataset with CSV file, run the code. So here's check, correct. Specify the file path. Now that the dataset is attached to the notebook, you can provide its file path. Do this by begin by clicking on the CSV file you'd like to use. And this will open the CSV file in a tab below the notebook. You can find the path towards the top of this new tab. So here. After you find the file path corresponding to your dataset, fill it as the value for my file path. Oh, he has the two dots. What? Oh, it has to be on string. I forgot about this the string. Nice. How do I just close like this? Here's the next code, so to load the data. After the code saw above, I'll check that. What? What the hell? Maybe I need to specify index. Uh, Something like that. And it doesn't have an ID. Well, I would have to set index. It has ID. I don't know what's going on here. It's giving me correct for the both inputs, but the data looks weird. Use the next code cell to create a figure that tells the story behind your data set. Use any chart type. Yeah, I have no idea. I don't think I'm gonna do this. I think it's a problem with the data, and then I would have to, if I really wanted to do this, I would have to figure out how the data, what's wrong with this. Because it is passing the tests. That's the weird thing. And here it seems like it's correct. So I guess it's the way that Jupyter Notebook is reading the data. That's not working. The way that it's parsing the columns. Maybe I need to do encoding. Should have eight, something like that. Yeah, I don't know. Maybe if I it's the same path. So copying from here doesn't make any difference. Maybe if I do this, it works. Just gonna save this and move on. 23 minutes. Maybe I can finish today. It failed, but I'm gonna move on. Okay, last one. So there are no exercises for this one. This final tutorial you'll learn an efficient workflow that you can use to continue creating your own studying data visualizations on the Kaggle website. Begin by navigating to the site for Kaggle notebooks. In the top left corner, click on Plus New Notebook. So right here. Explore and run machine learning code with Kaggle notebooks. This opens a notebook. As a first step, check the language of the notebook by selecting File Language. If it's not Python, change the language to Python. Notebook should have some default code. Please erase this code and replace it with the code in the cell below. This is the same code that you used in all of the exercises to set up the Python environment. Next step is to attach a dataset before writing code to visualize it. You learned how to do that in the previous tutorial. Then once you have generated a figure, you need only save. And so I guess that's it. Why it's saying that I not finished? Maybe I'll leave it like that. Correct. Step 4. I think I did all of them. I can just click here. It's easier. So apparently this one worked. Let's see if it changed anything here. It's still saying that I'm not finished. No, I think it's worked. Just gonna wait for the saving to finish here. We still have time though, so for the 2 hours I separated to do this. I'm gonna close this. Close this. Let's see if it works now. Oh no. Just this one that is it's gonna run everything. Oh, so that's the problem. I guess I'll try to delete this data set and add a new one. First one that I can see. Oops. Right. Right. Yeah, this one looks like it's working. Yeah, there we go. Save this. If I was going to do a project for real, obviously I would download the data and figure out what's wrong. But I think it's unnecessary to do this here. Nice. I'm gonna save this certificate and I'm gonna look for the other courses. And I think the next one I'm gonna do is gonna be Intro to Machine Learning. Seems to be the easiest one to give a progression. Maybe Intro to SQL. I saw this on Free Code Camp. Is a table structure thing, database thing, database language. I think we're gonna do Intro to Machine Learning next. So yeah, I think I'm done for today. And till next time. See you.